Hello people and welcome back to another video. In this video, we'll be continuing our discussion on hypothesis testing. So by now you have a basic idea of what hypothesis testing is, how do we go ahead and set up our null and alternative hypothesis, and how to actually surmise whether our alternative hypothesis is one-sided or two-sided. Now in this session, we'll be discussing the test of significance, which is fundamentally how do we apply hypothesis testing and move ahead in the process of statistical inferencing. Now, to begin with, what we discussed previously was that the null hypothesis and the alternative hypothesis is set up on the population parameters. So whenever we set up our null hypothesis, we always set it up on mu, which is the population parameter. Same goes with alternative hypothesis. Depending on if it's one-sided or two-sided, we set it up on the population parameter. So we have discussed earlier this idea as well, and we discussed while we were talking about statistical inferencing that the main idea of statistical inferencing is to study the sample, take out relevant insights from the sample, and extrapolate that to the population. So in this particular test of significance, we'll be learning exactly that, how to infer significant insights from the sample and make prediction about the population. So the first test that we are going to be studying is the Z test. But before we go into the Z test, I discussed test statistic in a previous session when we were discussing the idea of confidence interval. And I told you that confidence interval lies between estimate minus margin of error and estimate plus margin of error. Okay. This margin of error was defined somewhat like this. So this Z value, this is what is referred to as your test statistic. Right? So I discussed in a previous question when it asked about calculating the number of samples from the half width and the standard deviation. There I said that we'll be coming to a point where you can calculate the test statistic without having any preconceived table at your disposal. We'll come to that idea very soon. But what also needs to be mentioned is, what does test statistic actually tell us? Now, what fundamentally test statistic tell us is how far the point lies beyond the population parameter, which is taken in the null hypothesis. Now, let me reiterate what I said because it might be a little bit confusing at first. So, what test statistic tells us is how far beyond the population parameter that I conceived during initialization of my null hypothesis. So during null hypothesis, you go with the preconceived assumption that my population parameter is something. Test statistic tells us how far ahead does the parameter actually lie. That is something that we will be calculating from the sample that is there at our disposal. So to do exactly that, we'll be beginning with our first test, which is the Z test. Any test that you study now or in the future, all you need to do, and we'll be discussing this idea in a little more detail in the upcoming modules, but all you have to do is you need to calculate this test statistic and you need to compare it to the test statistic that is calculated at that particular confidence interval. You compare both of these values and you accordingly make judgments about your null hypothesis. So Z test is the first test that we'll be studying. Now we go and apply Z test to a sample where there are two a priori conditions. The first a priori condition is that the number of samples taken should be greater than or equal to 30. Here, the concept of CLT applies once again, and the distribution of the sample means will be turn out to be a normal distribution. The second a priori assumption is about the population standard deviation. So for Z test, your population standard deviation should be unknown. So population standard deviation is unknown, number of samples greater than 30. Then we need to go ahead and apply Z test to perform statistical inferencing using hypothesis testing. Now, the confidence interval, which is an idea that we talked about before, the confidence interval of the population parameter lies somewhere between x bar minus z at the confidence level multiplied by s by square root of n. This is the lower bound, and the upper bound is x bar plus zcl into s by square root of n. So this is my confidence interval for my z test for the unknown population parameter. Now, I'm going to be introducing you to a very pertinent point. I want you all to rewind this section of the video if you do not understand it for the first time, because this will be extremely important in all the further tests that we'll be doing in the later modules and throughout the course of the foundations of machine learning. This point is going to be of utmost importance. And the point that I'm trying to make is the difference between Z statistic and Z at confidence level. So Z statistic, or we can say the test statistic for the Z test, is given by x bar minus mu upon sigma by root n. Now this mu over here, this is my parameter value at null hypothesis. So if my null hypothesis says that mu is equal to 0, then this value will be 0. X bar is nothing but sample mean, sigma is standard deviation, and n is the number of samples. This is the population parameter at null hypothesis, this mu. This is the test statistic. This z value is the test statistic for z test. And zcl is the test statistic at a particular confidence level. Now, this confidence level will be already given in the problem. So the way to calculate z at confidence level is different from calculating the test statistic or the z value. Z statistic is calculated using this formula, and z at confidence level, this we will come to very soon. But the general idea is this is my Z value at that confidence interval or that confidence level. So if I have to make a graphical representation of this point, let me redraw this. If I have to make a graphical representation of this point, and I would say that what is the, let us suppose if I'm taking a null hypothesis and I have to find significant evidence against the null hypothesis as at 95% confidence interval. Let us suppose this interval is my 95% confidence interval. Let me highlight this in yellow. Now, this is my 95% confidence interval. This right here, let us suppose this is minus z and this is plus z. These two values are my z value at confidence level. Okay. Now, this is my expected value or the expected z value for that confidence level at null hypothesis. Now I have to see compared to this z value where my test statistic lies. So depending on whether I'm doing a one-sided test, and in one-sided test whether I'm taking the greater than side or the less than side, if I have if I have to calculate or I have to find evidence for, let's say, mu is greater than 0, then we will consider the right hand side and we will say if z is greater than zcl, then my alternate hypothesis or my evidence against null hypothesis will be proven true and I can reject the null hypothesis. If I have to calculate for mu is less than 0, what we have done in a previous question in a previous module, you can go and check that. Then I need to again look over here. Is z this is going to be my fundamental condition. Okay, so based on whether I'm taking my value on the right or the left, depending on that, we'll be formulating our condition for our hypothesis test. And this particular idea of how we calculate Z and ZCL will come back when we'll be doing examples on hypothesis testing. We'll be coming to this point very soon. But understand now that if this is my confidence interval, these are my Z confidence level values. My test statistic Z that I'm calculating from x bar minus mu upon s by root n, that can, if that lies beyond this, then we can say that it lies ahead of my confidence level and therefore we can reject null hypothesis. But if it lies somewhere in between, like if my Z statistic lies here, then we won't be able to reject our null hypothesis because it does not lie beyond the confidence level. We'll come back to this idea once again when we'll be solving a few questions. But now we will move on to the concept of p-value or the probability value. Now, p-value is calculated from the Z statistic. What I've told you right now with respect to the confidence level and the area, basically p-value converts that concept into a concept of probability. So now rather than comparing where my point lies with respect to the confidence level, I will be calculating the probability. So if, for example, I'm taking a one-sided test and I need to find evidence for mu is greater than mu naught, where mu naught is the initial condition in the null hypothesis, then this is the area which I'll have to be concerned with, because I'm finding evidence for Z is greater than Z, or mu is greater than mu naught. If, for example, I have to go to the opposite route, and if I have to say I need to find evidence for the lift condition, or mu is less than mu naught, where mu naught is the initial condition for null hypothesis, then this is the area which I'll be concerned with. Now, what if the test that I'm taking now, up until now, where we are analyzing only one particular area, when we are finding evidence for our alternative hypothesis, we are considering either the left hand side or the right hand side. What if my test is a double sided test, or I will say a two sided alternative hypothesis test? In that case, we have to find evidence for both less than and greater than. So we have to basically add both of these areas in case where we have a double-sided alternative test. Now, p-value is just like our test statistic, is another estimate of how far the exact value lies from the estimated value. Now, there is a condition: if my p-value is extremely small, then we can reject the null hypothesis. If my p-value is large, then we fail to reject the null hypothesis. So this is another point which we'll come to in later sessions also. We'll be repeatedly coming back to these concepts again and again when we'll be solving questions on hypothesis testing and test of significance. But for now, I think for this particular session, this much is sufficient. I would request you all to go through this session, and please make sure that you understand the difference between Z at confidence level and Z statistic. This is the main takeaway that you need to take from this video. In the next few sessions, we'll be solving more and more questions, and this idea of hypothesis testing, or Z test in particular, will be clear to you more. So with that said, thank you so much for watching this session. I'll meet you very soon in the next session. Thank you.